Hi everyone, so my name is Connor Tulluck and I work as a solutions engineer here at Nearmap. Today I'm going to be talking about a potential enterprise type solution which can assist with downloading high-res ortho imagery via our Tile API, and more importantly connecting our client to a database to facilitate better tracking and potentially set them up on a per project type basis for charge codes. So what I have here is a kind of a high level document kind of identifying what some of our pain points are here and why this solution fits in, as well as what some of the example front end, back end, and the database management is going to work. I'm going to keep this, as I said, a bit higher level. I really just want to kind of run through exactly how it would work, how the permissions are granted, and what the end goal of the entire solution really is. So right now, Nearmap has a number of ways to access our content. Fundamentally, for the engineering clients that we have, WMS is a really good solution. The WMS is a web map service that can plug into GIS and CAD applications and stream our content in natively once a server has been created that's tied to a customer access key. Now, this solution is really great for a lot of customers, but in situations where you may not have internet access or you're running multiple CAD windows and you're concerned with data usage, things like this may not necessarily be the best fit. An alternative would be using our web application map browser to export high-res georeferenced imagery. The limitation there is that we have resolution restrictions. There's a number of reasons for this, customer experience being one of them, but fundamentally the size of the query is restricted in terms of how much resolution you can get. As you go bigger, the resolution is reduced, and it doesn't necessarily fill that niche for a large area project that you need a max resolution for. So what we have here is a solution that leverages the Tile API. It allows a user to run a Python script, have a front-end access point to input a number of parameters that, such as date, what they want to do with clipping the imagery, if they want to reproject it, connect to their database, and then they're able to download and save locally that high-res ortho and then use that in whatever application they would like for any engineering use. So again, these are just kind of outlining some of the situations, the pain points that we're kind of seeing in the space. And then this is an example of what that front end is going to ultimately end up looking like, right? So you can see some of those input parameters I mentioned before, as well as the ability to select your input file that's going to define your area of interest that you want imagery on. Select your save location and then run the script, connect to the database, and save all of that. The example client input file here would be this example highway corridor, a little bit of a strange shape. Again, GeoJSON data format is what's supported at the moment. And then this is that output. So it's going to be a max resolution image for this corridor. Everything is going to be taken via the Tile API. It's going to be merged, clipped to the boundaries of the area of interest, and then reprojected to whatever EPSG code the customer has input. The schema that we save into the Mongo database is a NoSQL solution, so it's going to be just a JSON format. Again, we do everything we would do with a normal database on this structure, though. These are just some of the parameters that are being saved here. Different colors are going to indicate the different types of data that's being stored. We do a lot of things to keep track of just how the script is performing. We're keeping tabs on what the performance time is. If there's any error codes being returned, this specific example has an error code here. And then fundamentally, the most important piece of this is tracking exactly what the GeoJSON itself is. So one of the great advantages of MongoDB is that we can store GeoJSON data directly into the JSON structure itself. So there's not any conversion that's required. We can just store that object. And then in terms of that data tracking, there's a number of solutions that are built into Pymongo as well, which are fantastic. They have a application called Atlas, which will let you very quickly make tracking dashboards like this. You can see every line that's being printed out for the database. Again, there's only a couple entries on here. We have a map that's showing the center points of each query just to kind of geolocate where you're at. And then you could do things like actually sum up the total area of the queries for a client's account. There's some restrictions on this web map here. What I would love to see down the line is more support for some of those geospatial content types. So actually having a map that you can draw the limits of the GeoJSON. Right now they only support kind of point data and then more of like a scatter plot type thing, heat maps, things like that. So alternative, what I have is a Folium web map. Folium web map is it's a Python script you can run. It's going to go ahead and read the Pymongo database and then take all the GeoJSON objects and draw them on the map. So you can see all these blue areas here. They've been drawn. So that's indicating the extensive history of that client account where they've queried data. And again, you could read all of the metadata that's stored in the structure as well. This is just kind of a simple example. So next I want to talk about how the Pymongo database is set up, how the permissions are set up. How we allow our clients to write data to the database without actually reading the database. And then I'm going to move on to kind of talking about how the front end is run as well. So this is the Pymongo database here. Again, let's talk about access points to start. So for the database access, we can go to this tab here. And I have a number of testing accounts. So I actually have a number of SE accounts set up for testing purposes and really just have our own SE internal account. And what you want to actually do is go to network access, or I'm sorry, my bad on that. Let's go to custom roles. And so for custom roles, what we're going to do is set up a new custom role that can only write data to a specific client collection. So Pymongo's structure is that you can have multiple databases within each project deployment, and then you can have multiple collections within each database. So every client will have a specific collection that is fundamentally only their data. They can only write to that collection. So you can see if I go to our custom role here, you can go to your collection actions. And what we would do is we'd just go to the query and write actions. Let me uncheck these other ones actually, because we want to turn everything off. And then we would write a query action that can only insert data. Then you would specify the database. So I know we have one called nearmap. I've already kind of set this. Client. Client database is the database name, and then nearmap is the collection. Making that very specific so I don't forget to delete it. Then I'm going to add custom role, and you will see it pops up right here, right? So you can only write to the client database nearmap. That's it. I'm going to just immediately delete it because I don't need that. Then once that custom role is established, what you do is you set up your database users. So again, it could be as many or as few as you want. So let's go to our database user here. We're going to do another testing. We're going to go temp. And then what we would do is, instead of read and write any database, we would select a custom role. So I have a custom role here. Again, I actually just deleted my other custom role, but let's select the nearmap user testing one that I've already pre-established. Again, if you make one of the custom roles, they will show up in your custom roles here. And then we will hit add user. So again, this is the one I just created, my temp user. They can... Oh, I actually need to edit that. So they have built-in access already. So we want to delete this read write any database. They don't want that. So now you see in this temp line item here, it's nearmap user admin. Again, already set it up, only writing data, no reading data. So when on the application itself, when we run the front end, you'll see that we can input the user parameters and the password that I just set up, and they will then be able to push data into the database with their query itself. Okay, so now what we're going to do is run the front end of the application, connect to our database with our username that we just created, and then make a request for data and check to make sure that the database is working correctly. So let's run this front end here. Again, we're using PyQt on the front end with some of this UI. Project number is optional. Let's do our temp user that we just created. Actually just did this as a password for now. And collection name is nearmap. We're going to mask this. So what this is going to do is clip to our AOI. And we're going to bump up our tile size so we get a little bit higher resolution. We're not going to reproject. We're going to keep it in WGS84. And then we're going to select our testing file. So I have this file saved here that I've been using for testing. It's a GeoJSON in downtown Boston. And then we are going to save in our temp data folder here. So let's just do temp data. Actually, we should be good here, actually. Temp data. And we're going to run it. And we're going to give this a minute. It usually takes just a moment. Larger areas are going to be a lot longer. It's a lot of tiles to return. But on something like this where it's relatively small, it should be fairly quick. So our tiles have been returned. It's now working on merging and reprojecting. And then it writes the database. It looks like data download complete, writing to customer database, finish writing data. All right, awesome. So if we go to our temp data folder that we created, you see that we have a TIFF, some GeoJSON data, some additional files here. And then for our output, we have the final merged, clipped, and reprojected information. So if we go to our QGIS window here, this is the original AOI that we just used. We've OpenStreetMap loaded up. We close this, and then let me go to the output. We can drag our TIFF down. You can see that we have a clipped, merged, reprojected image at that max resolution of the dates that we just wanted, right? Which is great. And we can even check to make sure that the information loaded correctly with GDAL. So if we run that metadata request here, you can see that in fact our coordinate system is WGS84. Everything looks good there. So next step is going to be just to check that our database write worked correctly. So again, not necessarily on the customer side. They shouldn't have to ever worry about their data being written correctly because it's just happening on the back end. But for us, we want to make sure that things are actually working out the way that we're expecting. So let's go over to our databases here and then go to our collections. We can see that there is some write action going on here, which is good. That's what we want to see. And then if we browse to our nearmap collection, we should see a write that just occurred recently on that testing account. So we go down here, and here we are. So this is the most recent write. Our user is that temp account that we just created, and we have all the metadata that was associated with the input, and then also the tile size, zip size. We masked the file, which was that clipping method, and then we have the GeoJSON of the data query itself, which is great, which is what we really want. And then quickly, I think I'll just pull up that chart area that I was mentioning before for some of that dashboard utility. Again, not the only dashboard we would want to build out. It's probably the simplest and easiest, but it does highlight kind of the potential once the database has a good amount of write access and things like that. So you can see there's only been a couple of queries here. Got a few line items, but this is actually this is a comprehensive list of all of the queries on this database at the moment. I've been emptying it out pretty regularly, but here we have that temp write that occurred. Actually, let's sort by date, so it's actually ordered correctly. We have all of the information associated with it, how long it took to reproject the data, how long it took to download the data, if it was masked or not, ortho imagery, no error codes, which is all good stuff. And then, again, this is our query location. So this is actually just tracking the center point of the request. It's not actually graphing the geocoordinates because of the fact that it's a limitation of the Pymongo system at the moment. Hopefully it will be supported later on. And then we have this graph here that is tile size versus time to download, which can be helpful for some analysis. I'm actually on dark mode. Let me switch it out. I'm going to blind myself, but that's all right. So you can see, you can track exactly kind of how the performance is doing. And then also what the sum of the data requests is by user, another really helpful metric. And more importantly, something that can be used to track per project pricing and total area that's being requested by the user. So that's pretty much covers the kind of the full extent of the download tool, functionality of the database, and sort of what the advantages of leveraging this data, leveraging the APIs and Pymongo connection really can be. It's a really powerful tool. I think there's a lot of potential down the line to build this out and really improve that customer experience for the AEC and commercial space, where they have a little bit more of that niche use case in terms of how they're ingesting the imagery, and kind of work around some of those pain points of the platform at the moment. So again, thank you for watching. I hope everyone has a good day.